All right, so 4 primitive integer types. We have byte, short, int, and long. Technically, you could have put char here because I didn't say signed integer types here. So technically, chars are integer types. But I was looking for these 4. But if you put char, technically that is not an incorrect answer. Why do we have so many ways of storing whole signed integers? So our primitives came from C. And back then, memory was expensive. So we had to have granular control over how much memory we used. All right, and I'm looking for exactly those words in that exact order.
Oh my goodness.
Go ahead.
Blame the golf course.
Yeah, blame the golf course for that one. I did get 18 holes in yesterday, and like 2 minutes after I got off the last green, the sky's open.
I mean, at least you got out there when you did.
So what was your question?
No, it was about that, like what you wanted.
Oh, I mean, anything close. You know, memory used to be expensive, you know, something along those lines. All right, questions about that stuff?
The Supreme Court strikes down law.
What? No. Well, at least that's not the worst thing I've heard in a classroom this week. After the, well, yeah, you were at the Grace event, right?
Oh yeah. What happened?
I can't repeat that on recording. That was pretty funny.
That's what happened.
Huh? No, it was like at near the beginning when they played the video. Like, yeah, the starter video. I mean, it was funny, but definitely caught me off guard. And I'm not repeating it in class. Talk to your neighbor.
Because that was their whole like.
You remember me.
And then there was a reference to the comment in the cahoots of naming player names, but we got that one off of there. Okay, so. All right, so since several of you said you practiced this, help me write an error-free Hello World program. We are inside of a file called driver.java, so the class name must match that. What do I start off with? Public class driver.
Squiggly
thingy.
I can't remember the name of it.
Okay, curly brace. Opening curly brace, closing curly brace. Then what?
Constant void main string var
Loud noises.
I thought the brace was always by the end of R. Doesn't matter what it says beginning or end.
Out. Ooh, oh, there we go.
These computers can't keep up with me.
Echo without screen.
Needed 20.
It's like, why even turn the screen on if it can't keep up with me? It just throws me off. All right, so at some point you'll have this on a quiz or a test or multiple quizzes and multiple tests. You should be able to do this, if for no other reason than just to give yourself a quick and accurate starter point for any Java program. All right, so as of right now, I hit play. It says hello world down here. I know that I have a functioning Java program. Okay, so last time we talked about variables. Syntax for a variable is what? What's the generic syntax for defining a variable? What do we have to provide first?
The type.
The type. So what kind of animal are we storing? Then the name of the variable. Okay, and then the optionally the equal sign and the value. Okay. Why can't a variable start with a number? A variable name start with a number. Go ahead.
Because the number is a value associated.
Okay, so at the end of class last time, we were talking about variable resolution, and we had something like this on our, I think we had like int a is equal to 5, and then we had a system dot out dot println a, something like that. What kind of animal is a here?
What do you mean exactly?
No, I don't know. You have to tell me what I mean.
It just-
What kind of thing is a? Is it a char? Is it a number? Is it a variable?
It's a name for an answer, isn't it?
It's a variable. So a is a variable. Okay, and it's a variable that happens to hold an int. Now, how do we know that this is a variable name?
It's what you labeled it as.
Okay, so it doesn't look like this. We don't have single quotes around it.
That's for string variables.
That's for chars. Double quotes is for strings, so it doesn't have those guys around it. And it's not a numeric literal. So since it's none of those things, it must be the name of a variable, or it's an error, one of the two. All right, so since this is the name of a variable, we need to resolve it. What does it mean to resolve a variable? What am I ultimately saying when I say resolve a variable? Go ahead.
Go find what this guy means.
Yeah, find out what his value is. Okay, so this is a name, and this name maps to some value somewhere. So we're going to have to go and find out what memory address this guy lives in, then go to that memory address and ultimately find that it holds a 5. Therefore, at runtime, that A would get replaced with a 5 while the program's running. We would never see that happen, but that's what ultimately happens. It resolves the variable name to its equivalent value at that moment. Make sense? Okay.
So why can't a variable start with a name, with a number?
Well, if I had A start with a number, when it first starts going through there, if I said something like 5A, it's going to think that this guy actually is a numeric literal.
Okay.
And then it's going to start hitting stuff that aren't numbers and start freaking out. Okay, so questions about variable definition. And understand that right here, I've defined a variable. Copy this. So this is an example of me defining a variable. Here's an example of me using a variable. Here's an example of me changing a variable's value. So I'm not redefining it. That's why we don't need the word int in front of this. I'm not creating a new variable A. I'm modifying the value that lives in the current variable A. And then if I print it out, shouldn't I copy this? So A is 5, print out 5. A becomes whatever A currently is, which is going to get resolved to a 5. 5 plus 5 is 10. Store the result back into A. So A is now 10. Print out A. So this will print out a 5, then it'll print out a 10. There's our 5 and our 10. All right. So important thing here is know when we are defining a variable versus when we are utilizing that variable in some way, whether we're changing it, we're using its value directly, whatever it is. We only need the type defined there when we first define the variable. Make sense? Okay, so back to our list. How do human beings solve problems? We use memory, we ask questions, and repetition. So our second thing on our list would be, how do we ask questions? How do we ask questions in Java? Syntax for this is an if statement. So if, opening parenthesis, Boolean expression, closing parenthesis, opening curly brace, logic, closing curly brace. Then optionally, and I'll use that same syntax we had last time. So in square brackets, usually that's the optional parts. We can have an else clause, opening curly brace, followed by logic, followed by closing curly brace. So you can have an if without an else, but an else is always optionally part of an if. Okay, so this is the generic syntax for an if statement in Java. If, and notice when I type it, it makes it show up in purple saying it's a reserved word. Opening parenthesis. Now I need something that is a Boolean expression. What's a Boolean expression?
True, true, true.
Yeah, Boolean expression. This is any expression that boils down to a single value of true or false. Okay, or more concisely, true or false. That's accurate. All right. So I need an expression that boils down to true or false here. I could say something like a less than 10. So if a is less than 10, if that is true, I'll just print out something else here. We can print out woot. Let's get rid of this other stuff. All right, so I'll start A off at 5. If A is less than 10, print out woot. What will the output of this program be? What does A resolve to right here? A 5. 5 less than 10. What is that? True or false? True. True. So if this value in here is a true value, then we do execute the logic in between the opening and closing curly braces of the if statement. So this should print out woot. There's my woot. If I change the A to 50, now is 50 less than 10? It is not. That's going to be false. We'll skip past this, and the output of my program will be nothing. Optionally, we could throw an else on here. LOL or something like that. So now this will print out LOL. Because 50 less than 10 boils down to false. So we will skip this, fall to the else, print out this.
Don't you need the braces?
The who?
The braces.
Yeah. So he wants to know, why didn't I put this in there? All right. I'm showing you something you would see in a lot of books. This is a formal way of saying the stuff between this opening square bracket and this closing square bracket is optional. The opening and closing square brackets are not part of the syntax.
So essentially, it's pretty much like C#.
It's the same. It's identical to C#. All right. So the punchline here is that you don't need an else, but you can have an else. If you choose to have an else, the syntax is what I have highlighted there. The square brackets are not part of the syntax. It's just a formal way of showing that the rest of this is optional. Make sense? Okay, and that's not a Java thing. That's just this is a concise way of showing language thing, which LOL and woot. All right, so currently 50 is not less than 10, so it'll drop to the else and print out LOL. So there was my LOL. Now, we saw a few minutes ago that an else is optional. What would the output of this program be?
Root LOL.
Wouldn't it just be the condition when it's true then? It's not nothing.
What will the actual output of this be? What when if I hit play, what will I see?
With an LOL.
Well, A is 50. Is 50 less than 10?
I don't know.
Nope. So since it's not less than 10, will this code get executed?
No, just because.
Nope. So it's going to print out LOL. So when I hit play like that, here's my LOL. Notice it's the identical output that we had a few minutes ago when we had the else in there. Does that mean that the else is completely optional always? That it's not needed? If I change this back to a 5, what will the output be? 5 less than 10 will be, this is true. So since this is true, it will execute the body of that if statement, which prints out a woot. Will it execute this? Yeah, that's just the next thing in line after that if statement's over. So if I hit play there, there's my woot and my LOL, as opposed to if I encase that second LOL inside of an else, it will only do that when the Boolean expression is false. So all I did is I moved this LOL inside of the optional else, and now we will only see woot printed out. Make sense? Go ahead.
In Java, does it matter about do indents matter?
It does not, but one of the reasons we use Python as our first language is since Python requires indentation, that then forces you to get into the good habit of formatting your code. Java is perfectly happy if you put your entire program on one line. That doesn't mean you should do it. Yeah, so I would say pretend like Java does require indentation. Eclipse pretty much does it for you, so it won't make a difference. But it's indentation in Java is to make it easier for a human being to read, not because the Java compiler cares. Yeah.
So how do you know when you have to put a new curly bracket? Like we didn't have to do it before this.
Yeah, so the syntax for a variable, for defining a new variable, doesn't include curly braces as part of that syntax. Typically, when we think about curly braces, let me actually create a slide related to these. Because I'll actually say something else about curly braces here in a second. Well, I'll talk about that in a second too. So I'm going to call these guys a block statement. Okay, a block statement starts with an opening curly brace, ends with a closing curly brace, and in between has 0 or more lines of logic. Probably wouldn't put 0 lines of logic in there, but technically you could. You could have an opening and closing curly brace and not put anything in the middle. Okay, so this is called a block statement. Now, why do we use block statements? Block statements allow us to execute more than one statement in a situation where only a single statement is allowed. And let me expand on that a little bit here. So when I came to this if statement syntax back here, what I've shown you here is somewhat of a lie. This is the way you should always write it, but the official syntax for an if statement is if, opening parenthesis, Boolean expression, statement, followed by optionally an else, followed by a statement. All right, so then we got to go down to what is a statement? What is this guy that we're calling a statement there? Actually, it's going to be pretty hard to explain formally. We actually talk about this quite a bit in the language theory class, but for right now, let's just say a statement is something that is built into the language using some sort of valid syntax that's built into the language, but we only get one. Okay, we only get one of those. So for example, I can go into my code here, and since I'm only doing one thing here, I technically could omit those curly braces. That's still legal code. Okay, still works just fine. All right, now where things get a little sketch though, when we first look at this, I'm going to take the else out here. And I'm going to go ahead and change the A to 50. So A is 50. Is 50 less than 10?
No.
It's not. So since this is false, we would say, our guess would be we're skipping all of this, right?
Yeah.
Okay. But the output is cat.
But it's isn't responding to the condition if it's less than 10.
Well, this is where indentation, so this is an example where indentation has tricked us, right? Because since we indented this guy underneath woot, we are visually tricked into thinking it's actually part of what happens when this if statement fires. If you always use opening and closing curly braces, even when you only have one sentence or only one statement, you'll never be wrong, regardless of indentation. If you want both of these guys to be part of this logic here, to be part of that question, wrap it inside of a block statement, which then allows you to have more than one thing in there if you want, but it certainly now makes it clear, regardless of whether I've indented these guys or not. You should indent them, but it makes it clear that these dudes belong to this block statement, which is a single statement. So a block statement is a single statement that happens to house more than 0 or more statements. All right. So the way I teach it is that it's never wrong to have an opening and closing curly brace after an if statement, even if you only have one thing. Therefore, it would be in your best interest to always use the opening and closing curly braces following an if statement. Now, back to her question, when do you know when to use the curly braces versus when do you not? That starts coming back to this whole idea of maybe memorizing the syntax to a certain extent. Defining variables is not something that requires a statement. Okay, so if we were to generically write the definition of a variable, we would say this is the, well, I'll write it in the slides. Well, we already have it in the slides, actually. So defining a variable, it's the type followed by the variable name equals the value. So since nowhere in here is there a statement type, we would not have curly braces. They're not an option for us to use. So we only have curly braces when we have a block of statements, a collection of statements. And we see it here several times. What's a class? A class is a block statement that contains 0 or more somethings, statements. Here's a method statement. Opening, closing curly brace. So this guy has a block underneath it, so on and so forth. Yeah.
If you add the curly brackets where it's not supposed to, will it screw up your?
It'll scream at you. Yeah, it'll scream at you. All right, so then we get back to kind of what you said is it's going to be hard to keep track of all the curly braces. And this is actually one area where Eclipse is very beneficial to us, and I used to teach Java using Notepad initially as what you coded in until you got used to writing this stuff, and then you would appreciate what Eclipse is doing for you. Because Eclipse, every single time you put an opening curly brace, it puts a matching closing curly brace, right? So it's automatically doing that for you, where historically I would have said, if you're writing an if statement, when you first start writing it, put your curly brace, and immediately put your matching curly brace. Kind of like getting 2 pieces of bread out, then building your sandwich in the middle. Okay, something like that. So that's what I would do, is I would put the top piece of bread, the bottom piece of bread, then start writing your logic in the middle. Eclipse does that step for you, but try to appreciate that it's doing that for you. If you do start getting into a kind of a common error for beginning programmers is you might get an error that says, curly brace expected or extra curly brace, something like that. If you want to go through and check to make sure you have correct curly braces, it helps to count. Anytime you have an opening curly brace, add 1. Anytime you have a closing curly brace, subtract 1. You should have a 0 at the end. So this is a 1, 2, 3, 2, 1, 0. So at the very least, then we have curly braces that we have the correct number of opening and the correct number of closing curly braces. It doesn't necessarily mean they're in the right place. Yeah.
Is there like any reason why there's a space? Like why the parentheses isn't right before? Like why there's a whole line?
Why there's a space here?
No, like after the curly bracket.
13 and 14. Just looks nicer.
Oh, in here? Yeah. That's just spacing. In fact, like I said before, I mean, you can put every line of this all on one big long line. Java doesn't care. I wouldn't do it. It'd be very difficult for a human to read. But Java does not care about indentation. Humans care about that. Python, alternatively, requires indentation, which is one of the reasons it makes a very good initial teaching language, because it forces you into thinking about things from this goes here, this goes in the next line, and is part of the dude above it, so I'm going to indent. Make some sense? All right, so yeah, you don't have to have any of these spaces. I'm just doing it for a little bit of readability, that kind of stuff. Okay, so my recommendation would be whenever you have an if statement, always have an opening and closing curly brace underneath it, even if you only intend to do one thing. Similarly, if you have an else, always have an opening and closing curly brace inside of it, even if you intend to do nothing. It's completely legal to do nothing here. Okay, so right now I have A is 50, is 50 less than 10? It's not, so it's going to drop to the else, and I have a single statement associated with that else. It is a block statement that has nothing in it. Hit play, there's my program that does nothing. Okay. Somewhat of a waste of time, but legal Java code. Make sense? So it's never wrong to have the statement following an if or an else be a block statement, and then for you to put the stuff in there that you want to have in there. Okay. Questions about ifs and elses. This should match up to what you did in Python pretty closely. Okay, just a curly brace here and there.
And it's semicolon usually.
Yeah. Few differences, but pretty closely. Still the word if. Still a Boolean expression. Still indent the stuff underneath it that you want to happen when that Boolean expression is true. Still have an else optionally. Still indent underneath the else the stuff that you want to have happen when the Boolean expression is false. It's the exact same structure, just a little bit different syntax for writing it. Okay? All right, so that handles, where are we at here? How do we ask questions in Java? We have if statements now. How do we accomplish repetition in Java? Okay, we have, well, we do it through something called a loop initially. Then we also have functions. We'll talk about those too. So we have loops. We have 3 different kinds of loops. We have for loops, we have while loops, and we have do while loops. We also have a type of loop called a for each loop, but we're not going to see that yet. So for right now, we're going to pretend like we just have 3 types of loops: for, while, and do while. Okay, so we want to look at the syntax of these different guys. Now, on this slide, I'm going to emphasize a couple of things with these guys. For loops are what are called pre-check loops. While loops are also pre-check loops. And a do while loop is what's called a post-check loop. All right, now what does that mean? A pre-check loop, I'm going to put this on a separate slide. Checks the Boolean expression before executing the body of the loop even once. Therefore, pre-check loops, we can say the body executes 0 or more times, depending on what that Boolean expression boils down to. There's no guarantee that we'll ever execute the body of the loop in a pre-check loop. In a post-check loop,
That's the while loop.
do while loop. In a post-check loop, we execute the body once and then check the Boolean expression, because we check the Boolean expression after, post executing the body. So these loops execute at least one time. So for loops and while loops are this kind, pre-check. Do while loops are this other kind, post-check. All right, so a for loop, we would say, lends itself to counting problems. A while loop lends itself to problems where we do not know how many times we need to loop. And a do while loop lends itself to problems where we need to do something at least once. All right, so counting problems. These are problems where we need to do something like at least one time. So, or I'm sorry, where we need to do something a specific number of times. Like I want to print something out 10 times, or I want to do something 30 times, that kind of stuff. Counting type problems.
So you need to know the exact amount.
Typically, that's the way it would work. A while loop says we're going to keep looping until some condition is met. We don't necessarily know when that condition is going to be met. Now, I guess one thing I would say is you could accomplish anything that requires loops using any of these 3 loops. Just the different loops kind of lend themselves to certain problems that kind of make your life a little bit easier. All right, so a while loop lends itself to problems where we do not necessarily know how many times it's going to have to repeat. For example, the example I usually use is like, when you have a program that says press any key to continue. How long will it be until somebody presses a key or is able to find the mysterious any key? It could be a second, could be a week, could be a month, could be never. So have we pressed the key yet? 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 Over and over and over again until it's finally happened. Something like that. Okay, so a while loop might lend itself to that kind of problem. That doesn't mean we can't use it for counting problems. We'll see that here in a few minutes. Now, a do while loop is probably our least common loop. It's the loop we will see in the wild the least often. Not quite as rare as seeing the short primitive type in the wild, but still somewhat rare for a do-while loop. These are for problems where something has to occur at least one time. And what's interesting about that is it is related to a very common problem. So anybody, I probably mentioned it last semester, my guess is, but are there problems that you can consider that you might write code for that something needs to occur at least one time? I bet you every single one of you have done something related to this today.
I feel like I know, but it's just I can't remember the exact example I'm looking for.
And sometimes we're not, and maybe one of the reasons why we're not necessarily aware of it is because a lot of times it automatically happens for us. Authentication. So when we give our username and password for something, logging into Gmail or webmail here on campus, whatever, we have to provide it with that information at least once. And then we may have screwed up and it might want it again. Make sense? So that's a situation where we might say, do enter username, enter password, while you gave me a bad username and or password. Then ask again. Then ask again. You still need to get it at least once. Okay? So it's kind of a common problem for do while loops to be used for, but you know, the reality is you will see for loops very, 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 very often, because much of the time in programming, we are doing things based on counting. I want to go through every element of a list, for instance, using Python speak. In Java, we're going to call those arrays. Okay, but still, it's a collection of things. How many things are in the list? The length of the list. You might have 10 things in the list. You might have 40 things in the list. So you might have a for loop that goes through every element from bucket 0 all the way up to the length -1 number of elements in that list and does something. Okay, that would be a counting problem. You're going to see those very often. Similarly, a while loop. You know, you might use these. We think about when we did this last semester, but we're going to do it again this semester in Java when we're converting from a decimal value to some other base. We keep dividing by that base over and over and over again until we finally get a result of 0. We don't necessarily know how many times we're going to have to do that. We just keep going while the value is not 0. Does that make sense? Something along those lines. That would be a kind of a problem where a while loop might lend itself to that. And a do while loop, like I said, authentication. Some of you, it wouldn't be necessarily horrifically uncommon for you just to say, I'm going to do everything with a while loop. You could do counting problems with a while loop. I'll show you the difference here in a few minutes because scoping rules comes into play there. While loops become a little bit less helpful. And we saw this last semester as well, but I'll review it here. All right, so those are our 3 kinds of loops. Let me show you the syntax for these in Java. So a for loop. We use the keyword for, all lowercase, followed by an opening parenthesis, followed by a Boolean expression. I'm sorry, not a Boolean expression yet. Opening parenthesis, followed by, typically, we're going to say var declaration, followed by a semicolon, followed by a Boolean expression, followed by a semicolon, followed by var change, I'm going to call it, followed by a closing parenthesis, followed by a statement. That's the official syntax, even though I would say replace statement with opening curly brace, logic, closing curly brace. Always use curly braces for it, even though it's not required. All right, so let's see one of these in the wild. So see an example of it. So let's say I wanted to print out all the values between 1 and 10. So I could say for int I is equal to 1, I is less than or equal to 10, I is equal to I plus 1. System.out.println I. All right, so keyword for, opening parenthesis, variable declaration. So I've started a counting variable. So its type is int. Its name is I. You can name it whatever you want, but I, J, and K tend to be very common for loop variables. But you can call this guy cat if you wanted to, doesn't matter. So int I is equal to, this is where it's going to start at a 1. Then the Boolean expression, remember it's a pre-check loop. So it will ask this question before it executes the body of this loop even once. So then we're going to keep going as long as I is less than or equal to 10. Then we execute the body. Then we change our counter. Now, one thing I'll throw out here, this is the structure that I'm just going to say 99% of for loops will probably take. Technically, you could leave this blank and you could leave this blank. You don't have to put stuff in there. Similarly, you could put more than one thing in here. And you can also put more than one thing in here. You separate them by commas. Oh, this doesn't need another.
Semicolon at the end of I equals I plus 1.
The semicolon is part of the for loop syntax. Okay, so I'm showing you something here that you can do. Forget that you saw this for right now. I'm just kind of foreshadowing something you might see in the future. So for right now, 99% of the time when you create for loops, you will define a counting variable. You will ask a question related to that counting variable. You will modify that counting variable. That's the structure of a for loop, even though they're a little bit more elastic than that. And I'll show you a couple examples here in a second. All right, so this for loop is going to go through. It's going to start I off at 1. Then we're going to ask the question, is the current value of I, which is 1, is going to resolve I to its current value, which is 1. Is 1 less than or equal to 10? It is. So we will print out a 1, print out the current value of I. Then we will change I. I now becomes a 2. Ask the question again, is 2 less than or equal to 10? Yep, print out a 2. 2 becomes a 3. Is 3 less than or equal to 10? Yep, so on and so forth. All right, so this should print out all the values between 1 and 10. And if I change this to 100, now it'll print out all the values between 1 and 100. Just making that small little change. So this allows us to repeat something some number of times. Go ahead.
Why doesn't I reset to 1 at the beginning of the for loop, but it's still comparing in the middle? So, like, the loop will add 1, but why doesn't the value of I...
This only happens one time.
So it's just the first argument that only happens one time?
Everything before the first semicolon. Yeah, because technically you could say J is equal to 10 in here, and that would also only happen one time. Yeah, so everything before that semicolon happens one time. It's like your initialization for the loop. Yep, and then from that point forward, it's this, then the body, then the change. Then the Boolean expression, then the body, then the change, over and over again. Yeah.
So in this case, do you need the bracket before the for?
The bracket, this guy?
Yeah.
Yeah, because this opening and closing bracket, just cut this real quick. That is the opening and closing curly brace that's part of main. It's part of this function. It has nothing to do with the for. It just happens to be that our for loop is living within that function. And that function has a statement, a block statement associated with it. So that syntax is separate from the for loop, but yeah, it's needed, but not because there's a for loop there. All right, so this is our for loop that we'll go through. I'm going to switch it back to 10 just so our output's shorter. All the numbers between 1 and 10. Now, I mentioned before that you technically could leave this part here blank. And I could actually put it after, or put it before the for loop here. I could define a variable name I before the for loop, then do nothing in my definition section of the for loop, still ask the same question, still make the modifications to I, and then still print it out. So my output would be the same. Now we might say, well, why would somebody do that? Let me switch it back to the way it was before. And I'm going to go back in here because this is something that we need to be variable scope. So we have this thing called variable scope. Scope means where is a variable accessible? Okay, where do we have access to it? A variable scope is governed by the place where that variable was originally defined. So where we define a variable will give us the information that we need to determine where we are allowed to use that variable. Okay? I'll show you what I mean by that. This int I here, I know I'm defining a variable because I see my variable definition syntax. That is the type, the variable name, and then equals the value. So this is where it's being defined. And because I'm defining it as part of the syntax of this for loop, its scope lives and dies with that for loop. So when that for loop ends, I is no longer a known entity. And notice here that little squiggly red underneath here, I cannot be resolved to a variable. It's never heard of it. Because when this for loop ends, at the end of this curly brace here, once I move on to this line, we're now back in a world where I never existed. That make sense? Now, alternatively, if I take that int I is equal to 1, I just remove it from there, and I paste it before the for loop. Now, all of a sudden, I've moved its scope. Its scope is now anywhere from this point forward within this block expression. So its scope is local to main. Go ahead.
I actually have a question about the print. It's print in, right?
ln, print line, print. So that kicks it down a line. If you just say print like this, it'll put them all right next to each other. It won't press enter at the end of the line. Okay. Now, another thing I'll throw out here, I know I harped on it a lot last semester, is other than the things I specifically tell you to go and memorize, like the Hello World program, don't go home. I mean, you can if you want, but the way to learn this is not to go home and just memorize system.out.println. Memorize those things. The way to learn this is through repetition. Write these things over and over and over again. Okay, because that's when you're applying it to actual problem solving. So this goes back to last semester when I kind of talk about programming as being like a sport. Right? You can academically know what this stuff means. So I'm showing you this stuff today. It doesn't look all that bad, but if you want to write it yourself, it's going to be a struggle. You're going to forget a semicolon here. You're going to like, oh, where's the curly brace start? All these things are normal questions when you're a beginning programmer or you're just looking at a new language for the first time. Okay. The way to get past that is not to memorize the entire structure of the language. The way to get past that is to work with the language often until you make less and less and less mistakes. Fewer and fewer mistakes. Make sense? Okay. Now, most of you are not going to listen to that. Most of you are not going to go in to spend an inordinate amount of time on your programming homework because you're like, well, why should I spend all this extra time on programming homework versus my English paper or something like this? I didn't make the rules. Programming is hard to learn. So you can either spend the time and get good at it, or you can put in the effort you're putting into everything else and probably, unless you have a natural talent in picking this stuff up, probably not get all that great at it. Okay, it's not just because you're not doing it the right way. It's like a sport. You got to practice it. It's not something you can just cram for the night before the exam. You come in the night before the exam and you've just memorized a whole bunch of crap. You will put stuff on the exam that is, like they're words that officially exist in the Java language, but you need to put them together in an order that makes some sort of sense. And unless you've practiced that, it's not going to work out. All right, so plan on spending more time on this homework than you're likely going to be spending on homework in other classes. Just the nature of the beast. And at some point in time, it'll finally click for you. You'll realize the things you spent 10 hours on before, you can now do in 3 minutes. Because one thing you'll see is at the end of a lot of these assignments, the actual amount of code that you write isn't that many lines of code, right? You might have a solution to a problem that's 12 or 13 lines of code, but getting those right 12 or 13 lines of code is a little bit more of is easier said than done. Does that kind of make sense? So stick with it, but practice lots and lots and lots and lots of time in front of the computer typing this stuff out. Don't copy and paste very often until you're just bored typing stuff, because the more you type it out, the more tendencies you'll see that you're forgetting the ln, you're forgetting semicolons. That'll reinforce it for yourself that that's something that you need to do. Okay, you guys have maybe seen me in 200 when we were doing Python. Until about 10 minutes into class, I was putting semicolons in at the end of most of the statements until I converted over to Python mode, right? Because maybe the class before that I was teaching C# or something like that. They're all the same. You just got to get used to that little language, those little nuances. Okay, so again, here in this for loop, that first little section here is not required. Although, like I said, 99% of the time, pulling the statistic out of the air, but it's probably pretty accurate, you will always define your variable in there. In this particular case, since I defined it beforehand, I have access to it anywhere from this point forward, from line 6 on, all the way through line 11, because I'm still inside the scope governed by this main method, this block structure right here. Therefore, I have access to it outside the for loop. I also have access to it inside of the for loop. So in this particular case, it'll print out the 1 through 10 inside of here. But then after the for loop's done, when I go to print out I again, it has heard of I, because I was actually defined in a scope that is accessible out there. And it will be an 11, because the very last time through, I was 10, 10 became an 11. We asked the question, is 11 less than or equal to 10? It's not. So we fell past the for loop, got to this line right here, and that's where we will print it out again. So this will give us our 11. That makes sense? This actually plays into, this example here actually plays into one of the reasons why for loops are very popular for counting problems as opposed to while loops. While loops don't lend themselves to counting problems, even though you could create a counting problem with a while loop. If I go here and I want to create another for loop, so for int I is equal to 20, I is greater than 0, I is equal to I minus 2, something like that. And then I'll go ahead and print out I in here. Notice it's screaming at me about I. It's saying duplicate local variable I. I've already defined a variable name I here. Now, I could still do this. I could just say, okay, well, I'm not going to redefine it. I'll just use the existing variable and keep cooking. But generally speaking, when I say what, I mentioned when we define variables, you want to name your variables in a meaningful way so that, if you come back to your program in 2 weeks and you look at a particular variable, you can make a fairly decent guess on what that variable was built to hold. If the variable's name is first underscore name and it's a string, it probably is built for holding a first name. Okay, make sense? So you want to name your variable something meaningful. Now, how meaningful is a variable I? Generally speaking, we might call that a throwaway variable. We just use it temporarily to count through the numbers 1 to 10, right? So that's something we kind of want to use in the moment. We're not going to use it 5 minutes later. We're not using it later on in the program. It just was a nice little throwaway variable that we can use, and we'd like to be able to reuse it. So I'm going to go ahead and throw the int I back in here. And I'm going to move this stuff back into my for loop up here. And now you're going to notice that all of a sudden this second, well, this guy's still upset because now we've lost our scope for I out in the general population. It's only available inside the for loops. So this for loop defines a variable I, and we count through all the numbers between 1 and 10. When this loop ends, this particular definition of I has died. It's gone. So when I start the second loop and I create a variable I don't have to be concerned with previous versions of I or what was the last value of I when it came out of that previous loop. I'm starting fresh. I need to count through some stuff. So I'm going to create a variable name I, just like I'm creating it for the first time. I'll start this guy off at 20. I'm going to keep going as long as I is greater than 0. And each time through, I'll subtract 2 from it. So it should be 20, then 18. Okay, and I'll print it out each time. So then we'll see here's our 20, 18, 16, blah, 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 all the way down to 2. Because the next time through, 2 became a 0. Is 0 greater than 0? It's not. So we didn't print out that last 0. If I change this guy to greater than or equal to, then I would get my final 0 printed out there. Can make some sense? So scoping rules are a pretty important part of specifically for loops because it's probably where we leverage scoping most often, where we like to have that nice little throwaway variable just for counting through every element of a list or something like that and not have to worry about that guy kind of being left over or later on I start using this variable I forgetting I had a previous version of it. And then I put a new value in it, or I forgot to put a new value, and I'm relying on this old value that's completely unrelated to the code I'm working on right now. And I have this random 11 in there that's throwing my code for a weird spin because I'm doing math with something that had nothing to do with this. All right, so generally speaking, and maybe a good general rule, make a variable's scope as local as possible for solving the problem at hand. If you need its scope to be available outside the for loop, make it outside of the for loop. That's okay. That's not against the rules. If the problem you're trying to solve happens to benefit from that. Generally speaking, if you have a variable named I, that's a fairly unimportant variable except for the very localized use of it. So you're going to make that variable scope as local as possible. In this case, we made it completely local to the for loop. When that for loop's over, that variable's gone. And only make it more global as it benefits you to make it more global. Something you might find in some old programming textbooks is this idea that global variables are bad. Okay, a lot of programming textbooks kind of teach this idea. And maybe in general, that's a fair statement. When we talk about a global variable, we're kind of talking about a variable that was defined at the most visible scope. So at the kind of the very top of your program, so your entire program has access to it. It goes a little bit farther than that if we start thinking about multiple files in your programs and stuff like that. But generally speaking, it's saying that defining a variable that's available everywhere in your inside of your program is bad. Now, I don't just blanketly agree with that. Sometimes global variables are a necessity. Maybe they make your life easier. Maybe it allows 3 or 4 of your functions to all operate off the same value. But it's probably a good rule of thumb to not make all of your variables global. If you're doing that, that's probably out of laziness. Just saying, well, I don't want to have to screw around with where do I have access to the stuff, so I'll just make sure my variables are accessible everywhere. Now all of a sudden you start getting into large programs where you have 500 variables defined at the top. Things are going to start getting wonky pretty quick. So make variables as locally scoped as possible and only jump them up to the next scope outside of that when you need access to them outside of that. Okay? Something we are going to talk about in here when we get into the Android stuff is this idea of the what's the design pattern? It's escaping me for a second. Singleton. Something called the Singleton design pattern, which effectively says, here's an ultra global storage location for all the variables I want multiple screens in my app to have access to. I mean, that's the ultimate version of a global variable, and sometimes that just makes life easier. And we'll see examples of that when we go and do it, some of the alternate ways of doing it. And, you know, we'll make a pretty good argument for when sometimes having a variable global is useful. All right. So we have a decent idea without practice at this point, but what variable scope means. Okay. So that was our for loop here. So let me show you syntax for while loop. So while loop, pretty simple syntax, is while, open parenthesis, Boolean expression, closing parenthesis, opening curly brace, logic, closing curly brace. And realistically, this part right here is actually just a statement. But I'm telling you, you should always use a block structure. So while this is true, do the stuff in here. Notice that the while loop doesn't have any kind of built-in facility doesn't kind of nudge us in the direction of defining counting variables and stuff like that. Because it's asking us, it's really built for something else. It's built for doing something until some condition has become true. So if we go look at this, I'll go ahead and write the equivalent while loop to this guy. So we'll say int I is equal to 1 before the while loop, because while loops do not have a built-in section for us to define a variable. Then we'll say while I is less than or equal to 10, do something. What are we going to do? We're going to say system.out.println I. Then we're also going to say I is equal to I plus 1. So we've mimicked the same order of operation that happened inside of our for loop, but we did it inside of our while loop. So our for loop is going to print out the values 1 through 10. Then our while loop will print out the values 1 through 10. I am allowed to define another variable named I here because this version of I lived and died with this for loop. So it fell out of scope. Now it's as if it never existed. So I created a brand new one right here. All right, so there should be 1 through 10 2 different times. There's my 1 through 10. There's my other 1 through 10. All right, so are these guys, are they actually identical in terms of what they do? What's the difference between these two?
Well, everything was identified correctly.
I'm not talking about the syntax itself. I'm talking about the problem solving. So this guy printed out all the values between 1 and 10. This guy printed out all the values between 1 and 10. What difference can you point out between these guys?
The for loop allows for incrementation. That's the initial value. So like,
what do you mean different incrementation?
You can use instead of +1, +2, +3, whatever it is, half or divide, whatever. You can do.
I just did the same thing down there. So it doesn't allow for different. I just did the same thing. Yeah.
For loops allow for a more localized scope.
Okay, that's definitely a big deal. So this for loop provides us this nice little local scope where I can have things kind of tightly packed inside of that for loop. So in this for loop up here, I can't print out I afterwards. Says he's never heard of it. This while loop down here, I could. Because he has heard of it, because his scope is defined here, which means it's available from line 12 on inside of this opening and closing block statement. That make sense? Now, it could be that this isn't what you want. You don't want I to bleed out past the while loop. But that structure for the while loop, because of where I scope is, because of where it was defined, it is accessible outside of the while loop.
It's kind of local.
No, it's more global. It's fair to say it's more global than this I, but it's not global. It's only available anywhere inside of here, starting at line 12, because that's where we defined it. So it wouldn't be accessible if we had another function that we wrote in here other than main. It would not be accessible in there. So it's more global, but it's not what we would call global. All right, so that makes some sense? All right, so generally speaking, we would use a while loop for doing something some number of times where we didn't know when something was going to occur. So let me give you a, well, based on time, I don't want to give that example right now. We will see it soon. Okay, I want to show you the do while loop example. So these guys are similar. We've shown you a counting type problem with this, but we see that there's some scoping differences. Yeah.
Could you run that real quick? Because mine won't run. For some reason, I copied it exactly.
Oh, you're copying it exactly. It won't run because of this.
Oh, okay.
Yeah, that's an error because this guy's scope died.
Gotcha.
Yeah, so if I take this out, now it'll run. So we'll get 1 through 10, and then we'll get 1 through 11.
Okay.
Make sense?
Yes.
All right, so then syntax for our do while loop. Is do, opening curly brace, logic, closing curly brace, while, Boolean expression, closing parenthesis, and then you do need a semicolon there at the very end. All right, so if I come in here and I write kind of our same logic here, I can say I is equal to 1, so I'll just reset I. And I'll say do system.out.println I is equal to I plus 1. Keep going as long as I is less than or equal to 10. If I'm matching those guys up there. Semicolon at the end. So this will give us our 1 through 10 a third time. So we have 1 through 10, 1 through 11, and then 1 through 10 again. All right, and I will copy this code and put it on Slack. But for next class, what I want you to do is I want you to write a program that prints all of the numbers between 1 and 1 million that are evenly divisible by 5. So you should print out a 5, and then a 10, and then a 15, and then a 20. So get it? All the numbers between 1 and 1 million. So practice writing start with your hello world program, add some loopy stuff in there, probably a for loop since it's a counting problem, and print some stuff to the screen. Should be pretty easy, but it'll give you some practice typing this stuff. Make sense? All right, I will see everybody on Tuesday.